All right, welcome back to Lab 8, Exercise D. Again, this is one that you're not going to find in the lab manual. You're only going to be able to locate this and the supplemental reading in the modules, so definitely go ahead and take a look at that. For the most part, the presentation for this lab is just going to provide you a little bit more background information about global temperature patterns. When we are talking about temperature and temperature changes in the previous module, or for the previous lab, we just talked about how there is an unequal distribution of insolation that hits Earth's surface, and this provides another reason for why we have temperature changes or temperature differences across the globe. And so you can see the two graphs here show what the winter temperatures and the summer temperatures are depending on when it's winter in the northern hemisphere versus winter in the southern hemisphere. And so using those isotherms, again, these are a specific type of isoline, we talked about this previously, that specifically looks at temperature changes. You can see the distribution of temperatures across the globe and how those change depending on what season each hemisphere is facing. So there are four primary controls that impact global temperature, and that is going to be latitude, altitude, the land-water contrasts, or the relationships between land and water, as well as ocean currents. So for this lab specifically, you're going to be looking at altitude and the land-water contrasts. So let's go ahead and look at that. I am zooming in to one of the maps that was displayed previously so that we can get a better look at the temperature changes between, or how temperature changes from places that are located close to an ocean or near a large body of water versus inland areas. We can see that looking at Europe, which again is relatively surrounded by water for the most part, water has a more or less constant temperature, so that's going to help to regulate the weather or the temperature found in that area. So places that are closer located to water, have more large bodies of water surrounding them, are going to help to maintain a temperate temperature, meaning that the changes are not going to be incredibly drastic. In areas where we do not have water, again, that has a relatively constant temperature, obviously water temperatures are going to change a little bit too, but in places where we have huge land masses, we are going to have more extreme temperatures. So whether that is more extreme cold temperatures or also more extreme hot temperatures, this relationship between continental or ocean, right, that contrast, is really what impacts how intense the temperature changes can be. And we refer to this as continentality. If water or land masses didn't impact temperatures whatsoever, and if it was just the amount of insolation that is coming in from the sun, we would expect that the equator or the tropics are going to always be warmer and give or take the same temperature. And the farther we get to the poles, whether we go north or south, the temperature should be getting colder. So for the most part, right down here where we have a lot of water, you can see that just over the ocean, it's relatively straight lines, which is what we might expect if there was no impact from the continentality component, which I had mentioned, right? How much the land mass impacts temperature. And so you can see in the northern hemisphere where there is more landmass, that is throwing these temperature gradients out of whack when you compare it to the areas where there is a lot of water, right? So lots of water, relatively regular temperature gradients versus large land masses, that is going to impact the gradients of the temperatures, again, impacted by that incoming solar radiation, as land areas tend to cool or heat at higher rates, faster rates than water. So for this lab, we are assuming that the latitudes are the same. So when we're comparing two different points that have two different temperatures, we are going to be looking at two different locations that share the same latitudes. So what might change the temperature that those two locations are experiencing? One is going to be altitude, right? Elevation, how high above sea level we are. And generally, the higher you go above sea level, it's always going to get colder. We talked about continentality. If something is located inland, right, far away from an ocean or a large body of water, that means that the temperatures are also going to fluctuate more extremely. So there's a higher range or variation in that temperatures, and the marine effect, right, that is the impact on your temperature because you are located close to an ocean, is going to have a less intense range or less variation in temperature. So here you can see the average annual temperature ranges, showing that where we have this 5 degrees Fahrenheit or 3 degrees Celsius, that is not the actual temperature that exists here. That shows you that the range, the annual range, is only 5 degrees Fahrenheit. So that might mean the summer really close to the equator is going to be 90 degrees, and the winter is going to be 85 degrees, right? A range of 5 degrees. So if we look at the map, where are we seeing the most intense ranges, the most extreme ranges? We're back up here onto this huge continental component, right? So here we have an average annual range of 110 degrees Fahrenheit. So that's what we're looking at. We're looking at the differences from a latitude perspective. We're looking at the differences in temperature, assuming that the latitudes between two different areas are the same, and trying to factor in what physical characteristics there are that may be impacting these temperature changes, whether it's altitude, whether it's that continentality, and this is more or less what you're going to be looking at and deciphering for Lab 8, Exercise D. So go ahead and take a look.